one now again. Okay, so let's look at number 17. Question number 17. Let me turn this back this way for people at home if it froze up on us. 17 would be much less work. Same basic concept, but a lot less work. So number 17, we have f of x and g of x again. F of x is 4x, g of x is 2x3 minus 5x. Okay, so for part A, f of g of x. So again, starting with the f function. So 4, there's an x, so plug in what g is. So g is 2x3 minus 5x. Distribute your 4, you're going to get 8x3 minus 20x. And that doesn't simplify. For part C, they ask us again to plug in negative 2. So 8 times negative 2 cubed minus 20 times negative 2. Negative 2 cubed is negative 2 times negative 2 times negative 2, which is negative 8. Negative 2 times negative 20 is positive 40. 8 times negative 8 is negative 64 plus 40, which is negative 24. Okay, part B, we start writing the g function and plug f into it. Okay, so we start writing the g function. I see 2. Oh, there's an x. We plug in what x is, or what f of x is, 4x. So 2 parentheses 4x, then cubed, minus 5. Oh, there's another x. Plug in 4x again. Okay, if we do that, if we cube 4x, 4x times 4x times 4x, 4 times 4 times 4 is 64. X cubed. Negative 5 times 4x is negative 20x. Clean this up, 2 times 64 is 128x3 plus 20x, and then again we plug in 3. Plug in 3, we have 128 times 3 cubed minus 20 times 3. 3 cubed is 27, 128 times 27. 20 times 3 is 60. Okay, you guys get your phones? Someone want to punch in 128 times 27? I can't. Well, what if I could do? Let me see. You already got it?
No, I just got it right.
Okay, 64. Let's see if I can get this. 64 times 54, 32, 108, 16, 216, 8, 5, 12.
What is it?
Hang on. 64, 54, 32, 108, 32, 16, 216, 8, 432, 8, 432, 4, 432, 8, 64, 8, 64, 16, 17, 28, 17, 28, 34, 56? Is it 3, 4, 5, 6? All right. Don't ask how I did that. Actually, I tell you, you know what I did?
Saying random numbers.
No, I didn't. No. 128, here's how I can show you a little trick here. I know that 128 is a power of 2. So here's what I did. You got a lot of remembering. I was saying numbers to make sure I remember. Cut this in half. You guys cut 128 in half? 64. Double that. Think about it. If you take a number and cut it in half, then you double it, what do you got?
The same one.
Same thing. Cut this in half. 32. Can you double 54? You should be able to double that easily in your head. It's 54 and 54. 108. Cut this in half. 16. What am I going to write here? 200 and... What am I going to write now? 8 times what? Double 200 and 16. 4. Double 4, 3, 2. 8, 6, 4. 2, double 8. 1600. Double 64, 128. That's a tough one. That's 1728. Then double 1728. 3, 4, 5, 6.
That doesn't make sense.
I just keep doubling and halving. And I did that. Now, I would never, ever do that for something like 17 times 347. I would never do that. You can. I wouldn't. Why? What's the easiest number to take half of? Even numbers. If you could do that, but they're going to get decimals. I would not do that. But I know the 128, if you keep chopping in half, it's always going to be a multiple of 2. So, it's just something I picked up on once. Yes, ma'am?
Can we have to subtract
Oh, yep. Minus 60, thank you. 96, 33, 96. Thank you. Yeah, I forgot about that. I did all that calculating. Forgot the easy thing to do. Okay, let's do a much easier question now, number 19. This one's actually so easy that some students struggle with it. Okay? And I'm gonna say something, and then based on what I say, you should look at it and say, well, wait a minute. Okay? So I have f of x is the absolute value of x, and g of x is negative 7. So for part A, f of g of x. Okay? So we start writing the f function, but when you get to an x on the f function, plug in the g function. So what's the first thing I'm going to put if I'm going to start writing the f function? Absolute value. Oh, there's an x. What do I put in for it?
-7.
And then continue writing the f function. So what's the answer? 7. This is where you might get a little bit like going, wait a minute, this doesn't make sense when I ask you this, okay? For part C, you're supposed to plug in -2 for x. Plug in -2 for x.
There's no x.
So guess what I want you, okay, here's what I want you to do. I want you to look at this, plug in -2 for x, and then tell me what you got. And what did you just say? There is no x, so what are we going to write down? Oh, we got to write something.
X.
No. Okay, write this. Okay, I'll tell you what. Do exactly this. Write this down, and then when you get to an x, write down -2. So what do I write down?
7.
What else do I write? So guess what the answer is?
7.
Okay. There is no x, so you write down what you got. I told you to write down the problem, and when you get to an x, put in -2. Well, there was no x, so just write down the answer, which was 7. For part B, okay? So start writing, and again, think about what we just said. Start writing the g function, but when you get to an x, plug in f. So start writing the g function. What are we going to write? What's the g?
Negatives.
What do I plug in for x?
Nothing.
There is no x, so that's it. Now plug in, what are we going to plug in 3? Plug in 3 for x, what do we get?
-7.
If there's no x, there's nothing to do. I mean, it's kind of like this. If I told you in an Algebra 1 class to solve that for x, what would you have to do to solve that for x? Nothing. Why? Because there's no x. You just don't have nothing to do. There's nothing to do. Okay? So, I would never ask that in an algebra class. If I did that, it's because I made a mistake and I accidentally put a y instead of an x. Okay. Let's try a few more and then we'll stop for today. 21, number 21. Okay, find f following g of x and the domain of it, and g following f of x and the domain of it, okay? So we're plugging f into g and g into f, and what are the domains for each of those? So f of x equals x squared minus 3x, and g of x is radical x plus 2. Okay, so let's start with f. Remember, f following g of x is the same as f of g of x. It's the same thing. So you start writing the f function, but plug in g of x wherever you see an x on the f function. Start writing the f function. The very first thing I see is an x. So what are we going to plug in?
Radical x plus 2.
Radical x plus 2. What?
Squared.
Squared. Minus 3. Oh, there's a x there, so -3. What?
Radical x plus 2.
Okay. Let's clean this up. These symbols cancel each other out. Left with x plus 2 minus 3. Radical x plus 2. Okay, and I want the domain of this. Can I plug in whatever the heck I want for x? Give me one number I can't plug. Just give me one number I can't plug in. Don't start that conversation again. You're okay with -2. -2 is okay. Why? Why'd you say -2?
So it's going to make it 0.
And can you take the square root of 0?
Yes.
Very good. A couple days ago you said no. Yesterday you said no, you can't. Yes, you can.
-3.
-3 is no good. What's wrong with -3?
I don't think there's a number. You told us.
Not if it's imaginary.
Why? What are you talking about?
Can't remove radical or
Right, if you plug in -3 right here, you're gonna get a negative there, and that's imaginary. We're not dealing with imaginary numbers right now, okay? -2 is close. We gotta plug in numbers that are what? -2 is okay. We gotta plug in numbers that are what compared to -2? Bigger than -2 or smaller than -2? Okay, well, let's try like you said, let's try -10 then. Is -10 okay?
No.
Remember, we're backwards, we're talking negatives here, okay? Not smaller than -2, bigger. Like, can I plug in 100? Is 100 okay? Sure. So, your domain is x has to be bigger than or equal to -2. Okay? Can't plug in a number smaller than -2, because if you do, you're going to get a negative inside the radical. Now let's do g of f of x. Start writing the g function, okay? But when we get to an x, plug in the f function. So what's the first thing I'm going to write if I start writing the g function? Radical. Well, there's an x. Plug in what? X squared minus 3x. And then what? Plus 2. Okay. Now we've done this a few times in this class this year. Okay, it may not be real obvious right now what we do next. Okay. Any idea what we could do? It says x squared minus 3x plus 2. It's never a bad idea to do this.
Foil?
Opposite of FOIL factor. Let's factor this thing. Any numbers popping in your head when you see a 2 and a 3? What's so special about 1 and 2? Times 2, add to that. So this does factor to x minus 2, x minus 1. Okay? If you can answer this, I'll be very, 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 very impressed. But if you can't, it's really not a big deal. I don't expect you to be able to answer it. What's the next thing to do? Any idea? Not yet. No? No, I'm going to square root it.
Square it?
No. Draw a number line. Now we'll put two numbers on this number line. What are they? What and what?
1 and 2.
Why? It makes 0. They're the critical values, okay? 1 and 2. Make sure you put them in the right spot. And what number am I going to plug in?
100.
A big number. 100, a million, a billion, whatever. Okay? If I plug in 100, what's 100 minus 2 and don't say 98?
Positive.
100 minus 1 is a positive. A positive minus positive is a positive. And it's going to flip-flop because they're not raised to an even power. So what do we want? Where it's positive? We're talking about a radical right here. What are we interested in? Where it's positive or where it's negative?
Positive.
Positive. So where is it positive? Here and here. So what kind of numbers are we allowed to plug in? Numbers that are what?
Bigger than 2.
X is greater than or equal to 2? Can they be 2 or not?
Yeah.
Yes, again. X is greater than or equal to 2? Keep talking.
And less than 1.
I'm so glad you said that. And less 1? Can it be 1?
Less than or equal. I don't know.
Why could it be 2?
You can
Because
square
2 minus 2
it.
is 0. What's the square root of 0? 0. Can we plug in 1?
Yeah.
Yes.
It's the same thing.
Right. So what'd you say then? X is bigger than or equal to 2. What'd you say?
And less than
I'm
1.
so glad you said that. And X is less than or equal to 1. Okay? And I'm not making fun here. I'm so glad you said that. You said it wrong. I was hoping somebody would say it wrong. I can count on you to do that, right? That's not right. Think about it. Numbers you plug in have to be bigger than 2 and smaller than 1, or equal to. Think about it.
It's just not equal to whatever's in there.
Now, think about this, okay? Numbers you're allowed to plug in for X are bigger than 2 and smaller than 1.
You can't get negatives if you go all the way.
Okay, I tell you what,
Past.
put this on hold. You guys are thinking too hard. Seriously, you are. My parents. I'm going to tell you, I guess the age of my parents. I'm going to give you some clues about the age of my parents, okay? My parents, I'm talking about either one of them. They're the same age, okay? My parents are older than 70 and younger than 60.
Well, that's just.
Why would you say that?
Because that doesn't make sense.
Why doesn't that make sense?
You can't be both.
Why? You can't be older than 75 and younger than 60. You said X has to be bigger than 2 and smaller than 1.
Is it or?
It's definitely or. Why? Give me a number bigger than 2 and smaller than 1.
Because you can't do both.
It's impossible. There is no number bigger than 2 and smaller than 1. So it shouldn't be and, it should be what?
Or.
So does that make a big difference? Or that makes a huge difference. I'm glad you said it wrong. Okay? Or. That's not possible, okay? Now, if I told you my parents are older than 70 older than 70 or younger than 60, okay? Is that possible? They're older than 70 or younger than 60. Yeah. They're one or the, could they be 63? Could they be 63 if I said that? If they're older than 70 or younger than 60, could they be 63? No. Could they be 75?
Yeah.
Could they be 45?
Yeah.
That'd be a neat trick since I'm 50, but anyhow. So, okay, let's try maybe, how many more? So we already got the domain there. Let's see, it was 21, 22. Let's look at 23, maybe 25. We'll do 23, we'll see how long that takes, and we might do 25, and we'll stop for today. Okay, 23. So f of x is x squared minus 4. G of x is radical 3x. Okay, so let's do f of g of x first. So start writing the f function, but then plug in the g function for the x's. So the first thing I see on f of x is x. So do I write down x? No, I write down, what do I plug in for x? G of x. So radical 3x. So I plug that in for x squared minus 4. Okay? These cancel, and we're left with 3x minus 4. Now, what numbers can I multiply by 3? This is what's tricky here, okay? This is a tricky question. First of all, I mean, this question I'm asking you isn't tricky. What numbers can I multiply by 3? Any number. So is our domain all real numbers? You think so. You think you can plug into whatever the heck you want for x. Okay, when are you allowed to have negatives inside of a radical if you're not dealing with imaginary numbers? Never. Never, ever, ever. Never. I think you said this just the other day. You said one word, you said never. Keep that in mind. So, for example, can I plug in negative 5 for x? No, you can't. You might say, well, I times 3 by negative 5. Yeah, but back here, if I was to plug in negative 3 here, what's 3 times negative 5? Negative 15. What's the square root of negative 15? Not real, okay? Did you just say a second ago that you can have negatives and radicals if you cancel them out eventually? Is that what you said? You said no. You said one word. You said, when are you allowed to have negatives in there? Never. Never, okay? So yes, they eventually went away. You know, if I just had just this, I could plug in negative 5, but before we simplified it, I wasn't allowed to plug in, for example, negative 5. So what kind of numbers can I plug in? I mean, can I plug in 0 for x? Can I do 3 times 0? Sure. You're not allowed, what kind of numbers would I plug in for x that would generate a negative? 3 times what kind of numbers would give you a negative?
Less than 3.
Well, not,
Bigger than 3. Well,
careful, we're not adding, we're timesing. Could I plug in negative 1?
no.
Can I plug in negative 2?
No.
Negative 3?
No.
1?
Yeah.
2?
Yeah.
So what numbers can I not plug in? Negatives. So x has to be, because if you plug in a negative number, 3 times the negative number is a negative number, and you're not allowed to have that. So again, even though we simplified it, before we simplified it, had we plugged in a negative, we would have had a negative inside the radical. Okay, so this is going to be our last one for today. So start writing the g function. So the first thing I see on the g function is a radical. And I see a 3. Oh, there I see an x. What are we going to plug in for x? The f function, which is x squared minus 4. Clean it up. Radical 3x squared minus 4. Okay. So we can't have negatives inside of that. Okay, so here's what we need to do. This doesn't factor. This does not factor. Okay. So we need to find out what's going to make this 0. 0's okay. Okay. But anything smaller than 0 is no good. We can't have a negative. So let's find out what makes this 0. So 3x squared minus 4 equals 0. Yeah, I think you can answer how to solve this in 4 words. First thing you do is add 4. Add 4. Then what? Divide by 3. So x squared is 4/3. Last thing we do?
Square root.
Square root. Make sure we do the plus or minus. Okay? So if I was to plug in radical 4/3, we'd get 0. If I was to plug in negative radical 4/3, we would get 0. Is 0 okay inside the radical? Sure. Just can't be less than that, okay? What do we do now? It's on the board still. Shoot, it's on the last problem. What do I do now?
Number level.
Number line. Put negative radical 4/3 and positive radical 4/3. And if I was to plug in 100, you know what 3 times 100 squared minus 4 is? A positive. Negative, positive. So, what are we interested in? Where it's positive or where it's negative?
Positive.
Positive. So we're talking about x has to be bigger than or equal to radical 4/3. Put you on the spot there, Bigelow. There you go. Or x has to be less than or equal to negative radical 4/3. Okay. All right, we're done for today. A little bit of a confusing section, I don't know. All right, the rest of the time's yours, guys. Tomorrow during virtual day, if you would, just kind of at least